Hey there! Ready for a deep dive into something truly mind-boggling?
Always up for a challenge.
Well, today, we're tackling black holes.
Those enigmatic cosmic monsters.
They really do seem to defy the laws of physics.
You can say that again.
We're taking excerpts from pasted text to unravel the mysteries surrounding these gravitational behemoths.
It's a fascinating journey, that's for sure.
The big question we're grappling with today is, can we actually destroy a black hole?
And if so,
How?
what would happen if we tried?
What would it take?
To understand that,
Okay.
we need to start with what makes black holes so powerful.
Lay it on me.
Black holes exert an incredible gravitational pull.
Oh, yeah.
So strong that nothing,
Not even light?
not even light, can escape once it crosses the event
It's
horizon.
like a point of no return.
A cosmic vacuum cleaner with an insatiable appetite.
And every time a black hole consumes matter or energy, it grows even more massive.
Exactly.
It's like a cosmic game of Pac-Man where the ghosts just keep getting bigger.
That's a good analogy.
But how does that even work?
It all comes down to Einstein's famous equation, E-mc-Fon.
Ah, yes. Everyone's heard of that one.
Energy and mass are essentially two sides of the same coin.
Okay.
So as a black hole sucks in more stuff,
Right.
its mass increases,
Makes sense.
making its gravitational pull even stronger.
Oh, wow.
But here's the really wild part.
Okay.
Once something falls into a black hole, it loses all its individual characteristics.
So it doesn't matter if it was a star or a planet.
It doesn't matter if it was a star or a planet, a piano or a pineapple.
Piano or a pineapple.
It all gets reduced to just its mass, spin, and charge.
Wait, hold on. It doesn't matter if it was antimatter? You know that
Yeah.
stuff that's supposed to annihilate regular matter in a burst of energy?
That's the thing about black holes. They don't discriminate.
Oh, really?
The antimatter would still contribute to the black hole's mass and energy,
Interesting.
making it even more powerful.
Wow, so even the supposed arch nemesis of matter can't destroy a black hole. It just gets added to the cosmic buffet.
Precisely.
Okay.
And this actually reveals a surprising parallel
What's that?
between these cosmic behemoths
Uh-huh.
and something much smaller,
What's that?
elementary particles, like electrons.
Really?
Just like black holes, these tiny particles are defined by their mass, spin, and charge.
That's incredible. You're telling me these monstrous black holes and tiny particles share a kind of cosmic identity crisis? That's a serious aha moment for me.
It's one of those mind-blowing connections that makes you appreciate the elegant, yet sometimes bizarre
Yeah.
rules that govern the universe.
Okay, so if antimatter is off the table, what about forcing two black holes together? You know, a black hole versus anti-black hole showdown. Would that do the trick?
That's a popular question.
Yeah,
And it's easy to imagine a spectacular cosmic explosion.
I bet.
But in reality, it wouldn't quite work out that way.
Oh, really?
Instead of annihilating each other,
Okay.
their charges would cancel out,
Right.
and we'd be left with,
Don't tell me.
you guessed it,
A bigger black hole.
an even larger, more massive black hole.
So no matter what we throw at these things, they just keep getting bigger and better. There has to be some way to at least put a dent in them. What if we aimed for the event horizon itself? Is there any way to crack that cosmic shell, destroying the event horizon itself?
Yeah.
Now that's an idea. Is that even remotely possible?
That's where things get really interesting.
Uh-huh.
Um,
Okay.
You see, while a black hole can have spin and charge,
Right.
there are limits.
Okay.
Push those
Yeah.
limits too far.
Yeah.
And theoretically, the event horizon could dissolve.
Sol, as in it just vanishes.
Yeah, like it just,
Yep.
well, not quite magic, but
Okay.
you're on the right track.
Okay.
Imagine the event horizon as a spherical cage
Okay.
surrounding the singularity at its core.
Right.
That singularity is where all the mass is concentrated,
Okay.
creating that inescapable pull.
So the event horizon is like the bars on a cosmic jail cell,
Precise.
keeping all the bad guys locked up.
Yeah. When a black hole spins, it creates a sort of outward force,
Okay.
like a washing machine on high speed.
Oh, I see.
Imagine spinning a bucket of water really fast.
Right.
The water pushes outward against the side.
Right. Centrifugal force.
In a similar way,
Yeah.
a black hole's spin can counteract the inward pull of gravity,
Okay.
potentially causing the event horizon to essentially vanish.
Whoa. So it spins itself out of existence? That's mind-blowing.
It's a mind-bending concept for sure.
Yeah.
And the same principle applies to charge.
Oh, really?
If we could somehow overcharge a black hole,
Mm-hmm.
the electrostatic repulsion,
Right.
remember like charges repel,
Yeah, yeah. Yeah.
could also disrupt the event horizon.
So it's like we're trying to force feed a black hole until it bursts.
That's a good analogy. But
Yeah.
we need to remember that this is all highly theoretical.
Right.
Whether we could actually overspin or overcharge a black hole to the point of dissolving its event horizon
Right.
is still a topic of debate among physicists.
Yeah. I can only imagine. It's not like we can just pop over to a black hole and start throwing charged particles at it.
Yeah.
But hypothetically speaking, if we could, what happens if that event horizon does disappear? What are we left with?
That's when we encounter something even stranger.
Which is?
A naked singularity.
A naked singularity. Okay, that sounds a bit ominous. Should we be worried?
Well, a naked singularity represents a point where our current understanding of physics completely breaks down.
Oh, no.
The event horizon acts like a shield,
Okay.
hiding the singularity's infinite gravity from the rest of the universe.
Right.
It protects the fabric of space-time from potential chaos.
So as strange as black holes seem,
Yeah,
they at least operate within some rules we can try to grasp.
exactly.
Naked singularities, on the other hand, are a whole different ballgame.
Exactly.
All bets are off.
With a naked singularity, all bets are off.
Wow.
Imagine a point in space where gravity is so intense
Yeah.
that it rips apart the very fabric of space-time. Cause and effect might not work as we expect them to,
Oh, dear.
and our ability to predict what happens next would vanish.
So if we somehow manage to destroy a black hole's event horizon,
Right.
instead of solving a problem, we might unleash something even more unpredictable
Yeah.
and potentially dangerous.
It's a distinct possibility.
Oh, great.
Some physicists even theorize that nature has a built-in safety mechanism
Okay.
to prevent naked singularities from ever forming,
Interesting.
a way of protecting the universe from such chaos.
That's oddly reassuring in a strange cosmic way. But if destroying a black hole directly is out of the question, or at least incredibly risky, is there any other way to, well, get rid of them?
Yeah.
They don't exactly have a reputation for being, shall we say, neighborly.
You're right. They're not known for their friendly vibes, but
Yeah.
there is one way a black hole can die, a natural death.
What's that?
Hawking radiation.
Hawking radiation. Now, that rings a bell. Wasn't that something Stephen Hawking proposed? Something to do with black holes not being entirely black? You're right on the money. Hawking radiation. It's like black holes have a tiny leak, even though they're known for sucking everything in.
That's a great way to put it.
Yeah.
Hawking radiation suggests that black holes aren't completely one-way streets.
Interesting. So they're giving a little back to the universe.
In a way, yes. They actually emit a faint stream of particles, slowly losing mass over time.
So they're not completely inescapable then.
Not entirely. It's a mind-boggling concept that completely changes how we view these cosmic giants.
So even these seemingly invincible black holes eventually fade away. Is that what you're saying?
Exactly.
Wow. So how long are we talking here?
Well, it's an incredibly slow process, a kind of cosmic evaporation that takes place over unimaginable timescales.
I bet.
For a typical black hole, we're talking about a period far, far longer than the current age of the universe.
Okay, so it's not like we can just wait around for a black hole to disappear, but it's fascinating to think that even these powerful objects aren't truly eternal. It puts things into perspective, doesn't it?
It certainly does.
Yeah.
Even the most extreme objects in the universe are subject to change and eventual demise.
So to sum it all up, we've explored some wild concepts today. Destroying a black hole directly,
Pretty much impossible.
or at least incredibly risky.
Definitely.
Antimatter.
Nope.
Just makes it bigger.
Exactly.
But there's a glimmer of hope, or perhaps a whisper of inevitability in the form of Hawking radiation. It might be a slow process, but eventually even black holes fade away.
Beautifully summarized.
So it seems like the universe always finds a way to balance itself out, even when dealing with something as extreme as a black hole. Thanks for joining us on this incredible journey to the heart of black holes. Until next time, keep those questions coming and never stop exploring the wonders of the universe.